All right, here's page 2 of the ACT guide, problem 6 through 11. So let's get started right away. Number 6, we're going to start with marking up the diagram, which even on the ACT, even with multiple choice, you're always going to want to mark your diagram first because those problems aren't hard, they're just tricky. So you have to just make sure that you don't fall for any different tricks. So if AB is parallel to CD, so I'm going to mark AB and CD as parallel. AB equals CD, so I'm going to give it a congruency marking. And AF equals FD equals DE. So I'm going to go and give those a different marking as congruent. What can you conclude? So what we've got here are a couple of parallel lines. We've got some congruent sides. And what we really need are some way to use some of our triangle congruence theorems to be able to tell what is true or not. So let's see. With my parallel lines, I can see that I've got two parallel lines crossed by a transversal. I can see that I've got some congruent angles there, corresponding angles. So there are those. So I've got side angle side and side angle side. So I can say ABF and DCE are congruent. Now ABF and DBF, I don't have, let's see, I don't have a set of congruent lines or anything like that, of congruent angles or pairs of congruent lines for that one. And then same with DBF and DCE. It's this DBF triangle that I don't have enough tick marks or sides that are congruent to be able to say anything. So the only ones that are congruent by SAS congruence is number 1, and that's choice A. Now for number 7 here, the ratio of measures of two supplementary angles is 7 to 8. Which proportion could you use to find the measures of the angles? So the deal is we've got supplementary angles. I'm just going to draw them here on a straight line, and the proportion is 7 to 8. And if we know one of them is x, the degrees of the angle, then we know the two of them together do add up to 180. So we can mark our angles like that. So if I set up my proportion, I'm going to compare the 7 to the 8, and then the x goes with the 180 minus x. So that's number 3. Now, if I had drawn my diagram different, I put my 7 and my 8 there, but if I just said this angle was x and this one was 180 minus x, then I could compare 8 to 7 and x to 180 minus x. I could do 3 and 4 also. So that is choice D. The other ones really don't take into account the fact that there's this word supplementary here. So somewhere in your problem, you're going to have that 180 degrees from supplementary. Now, number 8 is a quadrilateral problem, and they're telling you that the two quadrilaterals are similar. So we just need to know that when things are similar, their perimeters are proportional, just like their sides are proportional. I've got a couple of pairs of sides that can match up. If I'm going to know the perimeter, I do need to find this missing side. So we're going to first start with a proportion to find missing sides. So I'm going to take AB, and AB is 12, and I'm going to compare it with HG. So HG is over here, and that's 4. And then from my big quadrilateral, I've got side AD, which is 21. And then this X right here, or HE, that's what's going to be the matching side. So I'm setting up a proportion, and I'm going to cross multiply. 4 times 21 is 84, equals 12x, divide by 12, and we get x equals 7. So this missing side here is 7. So that's not one of my choices, so they didn't try and trick us that way. But I do need to add up, and I need to find the perimeter of this side, the little shape, because that's the one I have all the sides for. So remember, perimeter of any shape is to add up all the sides. So I'm going to do 7 plus 3 plus 8 plus 4, and I get 22. So now what I need here is a scale factor. I could solve for these missing sides and add things up, but if I just know the scale factor, then I can take the perimeter of the little one and the scale factor. So if I look, the ratio between big to little, if I do 12 divided by 4, the scale factor is going to be 3. So if I take the little one and multiply it by 3, I get the big one. So my scale factor is 3. So I'm going to take my perimeter of my little one, and I'm going to multiply it by 3, and I get 66, which is choice C. Number 9, a ladder 6 meters long just reaches the top of a building, and its foot makes a 76-degree angle with the ground. So this is going to be a trig problem, and I'm going to use this problem to teach you a few things about trigonometry. We have not had a chance to cover trigonometry, and I have no idea, what the plan is for teaching you guys trigonometry someday, but I'm just going to show you a problem now and show you how to do trigonometry, basically. So first thing you want to do is draw a picture. So if you can picture this situation, we have a building and we have the ground. So here's my building and here's the ground, and then ladders, we know, lean against the sides of buildings. Okay, so there's my ladder. And my ladder is 6 meters long. So there's my ladder, and it makes a 76-degree angle with the ground. So what we want to be able to do is find the height of the building. So the height of the building, or the height to the place where the ladder touches it, I should have drawn my ladder more exactly at the top. We'll just say this is the top. I want to be able to find the height of the building. So the key to solving trigonometry problems, first of all, trigonometry is it's these magical ratios that always exist inside of right triangles. And we call those ratios, we have the sine ratio, we have the cosine ratio, and we have the tangent ratio. Now the sine of an angle is always the opposite side divided by the hypotenuse of the triangle. So if I'm looking at this 76 degrees, the side opposite is the height, and the hypotenuse is the 6 meters. So in Algebra 1, hopefully you learned about the Pythagorean theorem, and that's in right triangles, and we learned about the hypotenuse is always opposite of the right angle, and we learned a squared plus b squared equals c squared. And that's just relationships between all the sides of the triangles. So we know the hypotenuse is always over here opposite of the right angle. So the sine of an angle is the opposite over the hypotenuse. So the sine of 76 degrees would be h divided by 6. So that tells me right away that number 1 is possible answer. All All right, so our other trig ratios are going to be cosine, which is the adjacent side divided by the hypotenuse. And the adjacent side is over here. It's touching the angle. So that cosine ratio is not going to help me find the height because that would be this a divided by 6. So that's not really going to help directly. Let's see. And then tangent is going to be opposite over adjacent. So that would be h over a, which, we need to use this 6 somewhere. So the only other one that I'm looking at is choice B, and I'm wondering, where did they get this 14 degrees from? Well, in any triangle, the three angles have to add up to 180. So if I do 180 minus 76 and 90, I do find that this right here is a 14 degree angle. So if I took one of my trig ratios and I did the cosine of 14 and I wrote that as adjacent over hypotenuse, h divided by 6, and then I multiplied both sides by 6, I would get number 2 here. So 1 or 2 using trig would be true. And so that's why the correct answer for number 9 is choice D. And in the answer key it says SOHCAHTOA. So when you see sine is opposite over hypotenuse and cosine is adjacent over hypotenuse and tangent is opposite over adjacent, that's SOHCAHTOA. And that's just sort of a little memory clue we use to learn trigonometry ratios. So that's an example of a trig problem and what it looks like. I would urge you to go on Khan Academy if you are interested in learning about trigonometry. There are tons and tons of lessons and practice problems so you can see what trigonometry is all about. We are supposed to learn right triangle trig sometime in geometry, so that would be a really great thing for you to do. The next problem is from a chapter we haven't done yet, our circles unit. So I'm just going to show you how to do it and talk about some of the different relationships inside of circles and help you find the right answer. So the first relationship you're going to use is one that you already know about, and that is the angles inside of a triangle. So if I want to find this angle right here, it's in a triangle, and with the 87 and the 67, let's see, altogether that is 154, so that leaves 26 degrees right here for this angle. And there's a rule. These are called chords of a circle, and so whenever we have something that's not a diameter, if we have this arc AB, which is, they want to know the degree measure of how far around is arc AB. The rule is if you have an angle outside of the circle, then that arc is in relationship to that angle. So for number 10, let's see here. Okay, so just looked up a couple of formulas and some reminders for myself, and it looks like when I have this 26 degree angle here, what we've got are our far arc and our near arc. So 26 degrees is going to be half of whatever the far arc minus the near arc is. Then the other rule about inscribed angles and triangles is this 87 right here is going to, if I double that number, the piece of the circle that 87 cuts off. 87 times 2 is 174. And if I cut that in, or rather, that 174 is from here all the way around to here. So if this piece is 140 and the whole thing is 174, that means this little part of the arc is 34. And come to think of it, I don't really have to use this complicated formula. I just know that the whole circle is going to add up to 360. So right now I've got 100, 140, which is 240 plus 34. So I've got 274 degrees accounted for, and it's just this little piece that is missing. So if I do 360 minus 274, I get 86, which is the correct answer. So that is a little bit of circle math for you. There's some rules about the inscribed angles that are on the inside and inscribed angles that are on the outside. And at some point in your geometry life, you'll need to worry about that. But for now, that's just a little quick synopsis for how to do a circle problem. And let's look at number 11, last but not least for this video. We've got a square garden enclosed by a fence with a perimeter of 40. So whenever they start talking about geometry problems, I draw a picture. It's a square garden and the perimeter is 40. So I know all four sides add up to 40. So they must be 10, 10, 10, and 10. And it's going to be expanded, so it includes 300 square meters more area, but it's still square. So he can use the old fence pieces. The new area is going to be 300 meters squared more. So this area out here is going to add 300 extra square meters of area. So what is the area inside the little original garden? Well, remember, area of a square, we just do side times side. So the original was 100. We add the new 300, and we get 400. So if I have a new garden that has an area of 400, I can take the square root of 400, or I can ask myself what number times itself will give me 400. And I find that the new garden is going to be 20 by 20. Okay, so yay, I found the new garden length. And here it is with the ACT. They give you that tricky answer because that's like the easy answer. And we know with the ACT, we always have to go a little bit further and make sure to read the question. So he can reuse the old fence pieces. How much new fence does he need? Well, the old pieces, remember, he's got 40 feet of fence. And the new garden is 20, 20, 20, and 20. The new garden is 80. And he's going to use the 40 he already had, so I'm going to subtract that. And he needs to buy 40 more. And these are not feet, these are meters. Sorry, I was using the wrong units there. But he needs to buy 40 more meters of fence to enclose his new garden. So that's it for page 2 on the ACT practice. Thanks for watching.